Hey guys, in this session we're going to be looking at bearings. Okay, so to understand bearings, I want you guys to imagine a compass like this, and basically what it means is that when you face north, it's considered 0 degrees, and north is always considered straight ahead of you. I know it's not the true north, but that's how bearings kind of works out to be. So say if we have an angle like this, and if we want to find out what the bearing for this angle is, what the bearing is actually, what we need to do is, if we move the compass onto the angle itself, we can see that so we're starting from 0, so 10, 20, 30, 40, 50, 90, and all the way to 140. So this one has a bearing of 140 degrees. We'll do a few examples like this, and then I'll show you what a problem actually looks like. All right, so the next example, we've got a bearing, try and figure out the bearing of this particular angle here, and we can see that this has a bearing of 314 degrees. Okay, so let's do one more example. Now in this one we're going to work with an acute angle, but so when we put this, we're going to go from 0, and we can see that it's actually 40 degrees, but we don't actually write this as a bearing of 40. We write it with 3 digits, so we actually write this as 040 degrees. So that's just to start off with. Now we're going to look at the directions itself. So say for example we have a direction north, then we know that that has a bearing of 0, 0, 0. Northeast, so northeast is actually here, so that's going to be 045. East is at 090, and then we have southeast, which is going to be 135. South, which is 180. Southwest is going to be 225. I've got west, which is going to be 270, and we have northwest, which is going to be 315 degrees. Okay, so if we're talking about directions, those are the bearings that we are talking about. So if we're looking at, say someone says, oh, we're going in the direction of south, then that means they're going at the bearing of 180 degrees. Okay, let's have a look at a couple of problems and see how bearings come into play. All right, what you'll notice is that in this slide I've actually asked you to find the bearing of A from B and bearing of B from A. All right, so what I'm going to do is, first off, I'm going to split this up into two things. All right, I'm going to do bearing of A from B. Now, if it says bearing of A from B, what that means is that we've got A there and we've got B there. So because it's saying from B, so we're going to put north here at B, and we're actually looking for the bearing going this way, right? But if we look at bearing of B from A, then A is going to be there, B is going to be there. But because it's from A, our north is going to be here, and the bearing is going to look like that. All right, so I'd like you to see the two differences. So now what I'm going to do is I'm actually going to work out the angles. I'm going to create a little right angle triangle here. All right, so there we go, right angle triangle. 1, 2, 3, 4, 5. Now my base is going to be 5, and this length here is going to be 2, and I'm going to figure out what this angle is, which I'm going to call theta for now. All right, now if you haven't worked with trigonometry, I'd recommend you guys to watch the previous videos in this series to actually use trig to solve this angle here. So in this case, what I'm going to have is opposite and adjacent. So that's SOHCAHTOA. We've got to use SOHCAHTOA. So my opposite is, in this case, is 2, and my adjacent is 5. So then I have tan theta equals opposite over adjacent. Tan theta equals 2 over 5. So theta equals shift tan of 2 over 5, which gives me, what do I have? Shift tan of 2 over 5 is 21.8 degrees. So this angle here is 21.8 degrees. Now, because of parallel lines, I could also probably do it something like this, where I could say, well, or actually I can say alternate angles are equal in parallel lines. So I could also say that this angle here is 21.8 degrees, which means to find the bearing of A from B, all right, this is what my bearing looks like. Okay, what I have is I have this angle here, which happens to be 21.8 degrees. But I also have 270 degrees this way, okay? So that means the bearing of A from B is going to be 270 plus 21.8 degrees, which means it equals to 291.8 degrees. But if I look at bearing of B from A, then this is what it looks like. All right, I know that the little angle here is going to be 21.8 degrees, and I have 90 here, so it's going to be 90 plus 21.8 degrees, which means it's going to equal 111.8 degrees. So that's the difference when we're talking about find the bearing of A from B and B from A. So notice the two differences there, folks. Do one more question and then we'll finish off for the session. All right, guys. So for this next question, I'm actually going to do it in the next video following bearings 1. It's going to be called bearings 2, and I'm doing this question in that video there. All right, now if you have any other questions, pop it in the comments below and I'll try my best to answer them. Okay, thank you for watching, and make sure you watch bearings 2 and bearings 3 in this playlist. Hey guys, welcome to bearings 2. We'll be looking at that problem that I mentioned at the end of bearings 1 video. Okay, let's get going. Okay, so in this question it says a tourist travels in a bearing of 45 degrees for 25 kilometers to point B from point A, then due south for 16 kilometers to point C. So we're trying to find the distance between C and A, and what is the bearing of A from C. All right, so we're gonna need to use SOHCAHTOA, but let's actually work out the problem. So what I'm gonna do is I'm gonna put a little dot here, and I'm gonna call this point A. Now he's traveling for 25 kilometers on a bearing of 45 degrees, so that's going to be 45 degrees, that's going to be 25 kilometers. Then it says due south. South has a bearing of 180 degrees, and he's going for 16 kilometers. Okay, so that's 16 kilometers. Find the distance between AC and what's the bearing of A from C. I think it would have helped if I had drawn a bigger diagram. So let's see, I'm just going to draw it here. So I'll put this as A, that's going to be B, and that's going to be C. So as you can see, what I'm looking for is, I'll put it in here, I'm looking for the distance between C to A. So that's the blue part there. Then I'm also looking for what's the bearing of A from C. So bearing of A from C. So from C, it means it's from here to there, and I'm looking for that bearing there. Okay, so what I do know is I know that this is 25 kilometers, and I know that this here is 45 degrees. So what I could do is I could actually, I'm going to put an extra point here. I'm going to call this point D. I'm going to figure out what AD is and what DB is. All right, because that means if I figure out what AD is, then I can use AD minus BC to get this little part here. And then if I figure out what DB is, I know what this can be written as DB as well. So the first thing I'm going to do is I'm going to work out AD. I'll put it in a different color so you guys can see it. This is what I'm working out first. So in this situation, I've got 45 degrees, the unknown, and this is going to be 25 kilometers. So using SOHCAHTOA, this is going to be hypotenuse, and this is going to be adjacent. So I have cos 45 equals adjacent over hypotenuse. So cos 45 equals x over 25. Therefore, x is equal to 25 times cos 45, which equals, what do I got? 25 times cos 45 is 17.67. Now, if x is 17.67, I could work out what, let me choose a different color. I could work out what this distance here is, because the 17.67 is the green line here, all right? If that's the green line, and we already know what BC is. BC is actually 16 kilometers, okay? I'm going to put another point. I'm going to call this E, all right? So I can see that CE, so CE, which is the gold line, CE is going to equal 17.67 minus 16, so it's equal to 1.67. Now I need to work out what DB is, all right? So DB is, I'm going to call this DB as Y. I'm looking for a different color, folks. Give me a second. Purple, there we go. DB equals Y, because this part is DB, Y. This is the part I'm looking at. all right, because I'm trying to figure out what dB is, which is the same distance as AE. Now, with dB, obviously, I'm going to use this triangle here, and I can see that that's going to be opposite. Now, if you're really quick, you can actually see that this is a 45-degree angle, which means this will also be 45 degrees. So y should be the same as 17.67, or you could use Pythagoras to prove it. So 25 squared minus 17.67 squared. Yeah, let's actually do Pythagoras. So what I want you guys to see is this right here. So see how this triangle looks like this. That's 25. That's 17.67. So, and if I put y as that top line, then we can say y squared equals 25 squared minus 17.67 squared. And so I get y is equal to 25 squared minus 17.67 squared equals that. I get 17.68, but it really should be 17. I probably did a rounding error somewhere. Okay, so now I've got that bottom triangle sorted out. When I say the bottom triangle, I'm looking at AEC. Okay, so that's AEC. So the gold part, I figured out what the gold part is. That's 1.67. AE is the same as DB, which is Y, which is 17.67. So now I can actually look at the question and say I'm looking for the distance AC, which is that. And to find the bearing, I need to work out this angle and add 180 to it. So first work out AC. So AC equals 17.67 squared. Well, AC squared equals 17.67 squared plus 1.67 squared. I'm using Pythagoras for it, guys. So 17.67 squared plus 1.67 squared. And then I get the distance of 17.75. And as for the angle, I need to do opposite and adjacent. So that's going to be opposite. That's going to be adjacent. I'm using tan. Tan theta equals opposite over adjacent. Tan theta equals 17.67 divided by 1.67. So theta equals inverse tan of 17.67 over 1.67. Theta is inverse of that. So shift tan divided by 1.67. So I get an angle of 84.6 degrees, which means for the bearing, I've actually got to add 180 to it. All right, so I actually get a bearing of 264 degrees, 264.6 degrees. Now I hope you can see why I'm adding 180, because if you look at the original diagram, this angle here is 84.6, and this extra bit here, that's that 180 that I needed to add. So that's how I get 264.6 degrees. Cool. I'm gonna actually leave this problem here, guys. Should I be doing one more? I have one more problem. I might as well do it, but I'll probably go a little bit faster, guys, so I wouldn't actually explain it as this much detail, yeah? But let's see anyway. Let's see how long it takes. All right, guys, so this question here is going to take about a good 7 to 8 minutes. So this will be covered in bearings 3 video. Now, if you have any questions about the previous question that we just did in the previous slide, pop it in the comments below and I'll try my best to answer them. Cool. Thank you for watching. Hey guys, in this session we're going to be looking at bearings. Okay. All right, guys. So in this question we have pretty much similar to what we did in the previous question, but we're just adding on an extra bit here. So from A, tourist is traveling to B. So the bearing is 45 degrees and it's for 25 kilometers. And then from B, they're traveling to C, which is 16 kilometers. And this is at a bearing of 125 degrees. So at the moment, we are trying to figure out what AC is. And we're also trying to figure out what's the bearing of A from C. So we're also looking at this bearing here. So really what we're going to be doing is we're going to create a little right angle triangle that looks like this. All right, so we're going to need to know what the base length is, and we're going to need to know what the height of that little triangle is. Okay, so for this question, guys, what we're going to do is we're going to split these two into two triangles. All right, so from A to B, we're going to split it up into a triangle that looks like this. So this is AB and purple, so it's going to have that purple triangle. And then we're going to get a second triangle, which is going to be an orange. That's for basically, that's going to look like this, which has BC in it. Okay, now one thing to understand is that because we have a bearing of 125, we can go 125 minus 90 equals 35. So this little angle here is going to be 35 degrees. So what we then have is we have two triangles. All right, first we have the purple triangle here, and I need to figure out what the opposite side is and the adjacent side, what the distances for those are. And for the orange triangle, I have to work out the opposite and the adjacent, where hypotenuse is going to be 16. And for the purple triangle, the hypotenuse is going to be 25. Okay, so using SOHCAHTOA, I'm able to actually work out all those four values there. All right, so I'm going to do the purple one first. So with the purple one, what do we have? I'm going to work out the opposite first. All right, so I'm working out the opposite, which means I'm going to be using sine rule. So sine 45 equals opposite over hypotenuse. Sine 45 equals opposite over 25. Therefore, opposite is equal to 25 times sine 45, which equals to, I just realized I actually worked this out in the last slide. So that's 17.67. Okay, so this here is 17.67. Now, because it's a 45-degree angle, it's an isosceles triangle, and I think I already proved this in my last previous example that the adjacent is also going to be 17.67. Okay, so that's the purple triangle. Now I need to work out with the orange triangle. With the orange triangle, I have sine 35 equals opposite over hypotenuse. So sine 35 equals opposite over hypotenuse is 16. Therefore, opposite is equal to 16 times sine 35, which equals 9.18. So this distance here is 9.18. So because from the orange, for the orange triangle, the opposite side is 9.18 and the purple one is 17.67, I could now work out what this little blue line here is, because that's just 17.67 minus 9.18, which equals 8.49. So for this little light blue triangle, the height is going to be 8.49. Okay, now I need to work out what the adjacent side is for the orange triangle. So I'm going to be using cos. So I've got cos 35 equals adjacent over hypotenuse. Cos 35 equals adjacent over 16. So adjacent is 16 times 35, which equals 13.1. Okay, so this one here happens to be 13.10, which means the bottom light blue line is going to be the 17.67 plus 13.10, which happens to be 30.77. So the distance from AC is going to be 30.77. So now, folks, I have the little triangle that I need to be working with, because I have a right angle triangle where this is 30.77 and this is 8.49. So using Pythagoras, I work out 30.77 squared. So this is, let me just write it up. So hypotenuse squared equals a squared plus b squared, which means I have 30.77 squared plus 8.49 squared, and I'm going to get h equals to 0.49 squared, sorry, h squared equals to 1018.87. so the h is equal to square root of that, which happens to be 31.91. So the distance between CA's distance is 31.91 kilometers. As for the bearing, I need to work out what this angle is and add 180 to it, because remember, north is going to be here and I've got 180 degrees that's coming from north to south. So to work out the angle, I'm going to use tan, because I have opposite and adjacent. So where opposite, this is going to be my opposite and this is going to be my adjacent. So I have tan theta equals opposite over adjacent. Tan theta equals 30.77 divided by 8.49. So theta equals inverse tan of 30.77 over 8.49. 30.77 divided by 8.49, and that gives me an angle of 74.57 degrees. But remember, to get a bearing I need to add 180. So in this case, bearing is 74.57 plus 180, and that's going to give me 254.57 degrees. Cool. So that's basically it, guys, for this particular problem. I know it was a huge problem, but I think if you watched by the end of this video, you should really have all the bearings sussed out. If you have any questions, pop it in the comments below and I'll try my best to get back to you. But apart from that, that's it for this extremely long session. Thank you for watching.